What is STEM, and how does after school fit into the equation? The Missouri After School Network, in partnership with the Missouri Math and Science Coalition, hopes to help answer that through our STEMtastic series that will periodically feature different STEM-related activities, programs, and issues specific to after-school programs. So what exactly is STEM?
What is this STEM I hear about?
Oh, that's easy. Science, technology, engineering, and mathematics.
But I've heard of STEAM.
What? You're blowing hot air.
No, really, what is STEAM?
STEAM is science, technology, engineering, arts, and mathematics. Many folks believe that the arts are an integrated aspect to STEM. They feel like design plays a key role to architects, engineers, etc. So that is why it should be STEAM, not just STEM.
But then there is also Stamper.
What?
Also STREM.
Huh? Don't forget metals.
Who?
What?
STEM with logic added. The acronym is changed to make sense, but not so much so, huh? However, most of the folks in education, business, industry, and the government use STEM: science, technology, engineering, and math. So let's stick with that and make like a robot and move on down the line. We learned a bit about the definition of STEM, but why does it matter and what does it look like in the after-school setting? Since STEM is all around us and we use it in every aspect of our lives, it is only natural to teach it to students. In fact, it's obvious that young students, especially in grades K through 5, are inquisitive. They question everything and have a natural love for discovery. STEM by its nature is hands-on, project and inquiry-based learning at its finest. Always students love to learn. The after-school space has the ability to really engage students by adding as much STEM programming and activities that make sense for a given program. This can be done in partnership with the traditional school curriculum or simply standalone as a program sees fit. But the reality for us in after-school space, STEM engages and excites kids of all ages and demographics and has been proven to help students succeed in their day-to-day education experience.
So this change in technology and what we know about our lives has transformed us exponentially even in the last few years. Tinker toys, Legos, to FIRST Robotics, drones, and more.
The scientific method is an 8-step process to ask and answer scientific questions. Step 1 is to ask a question that you wish to know the answer to. Step 2 is to hypothesize or to make your best guess based off of the research that you've done. Once you've gathered your information and made a prediction, identify what steps you will take or procedure with clear directions of how you will experiment. While conducting the experiment, it is important to collect data, as data analysis is step 5 in the chain of the scientific method. Data can be notes or basic observations about what you see. After you've completed the experiment and analyzed the data, it's time to draw a conclusion. What did you find? Was your hypothesis correct? It's important to note that it's okay for your hypothesis to be wrong. That's science. It's what you learned from the experiment that is important. Finally, the abstract is the summary of your findings, which is presented in the last step of the process, presentation of your entire process. As you can see in the 2 graphics listed above, the steps to the engineering method are quite similar, with the exception that the engineering method repeats brainstorming, development, and testing until the solution meets the requirement. For this experiment, we're going to be learning about density today.
Okay, what's density?
Density is a term that refers to how much stuff is packed into a certain area, and there's an equation for it too.
Okay.
Density equals mass divided by volume.
Okay.
Okay, so what we're going to do is we've collected some simple household products: honey, dish soap, syrup, water that we've dyed green so that it shows up, rubbing alcohol that's been dyed purple, and vegetable oil. Ellery, what I would like for you to do is feel them, swirl them around, and put them in order of what you think is the heaviest to the lightest.
Okay. This is pretty heavy. Kind of lightish. I think that should go there. This one is a little heavier than that one, I think. Okay, I got Here's the heaviest one, the second heaviest one, the third heaviest, definitely fourth heaviest, fifth heaviest, and lightest.
Okay, awesome. So now what we're going to do, we're going to test your hypothesis. So what I want you to do, going in order from here to here, is to pour them in and try not to touch the sides of it.
Okay.
So which one is this one first?
I think it's the honey.
Okay. All right.
That is a little on the side.
That's okay. Okay, so now for your next one is, which one's this one?
It looks like this is soap to me, kind of.
I think that one's our syrup. We dyed it yellow.
Okay.
Okay, so now we've got syrup. So what do you see happening whenever you pour it in?
It kind of gets bigger and it gets taller, definitely.
Okay.
Kind of. And it like soaks into the one before it.
Okay.
What?
Okay, this one is the dish soap.
Yeah. It's turning a different color.
From the top it is.
Uh-huh.
Can you look at it from the side and tell me what you see?
I see different colors, like orangey red, and then a blue, and a little green.
So do you think they're mixing together or are they staying apart?
Mixing together.
Mixing a little bit?
Uh-huh.
Okay, this was your next one. And this one is the rubbing alcohol.
Okay. Well, now it is turning darker.
Okay,
Super dark.
super dark.
And,
That one is the water. That one's just plain water with green food coloring.
okay, it's getting more liquidy.
Okay.
A little more liquidy. And now it's getting a little bit lighter.
Okay, so let's take a minute
And really bubbly, near the top.
So this one was the vegetable oil, and this is the last one that you poured in.
Uh-huh.
Is the vegetable oil staying on top, or are other things moving above it?
Other things are moving above it, and I think right there is where it is, sort of.
I think you're right. So what does that tell us about the vegetable oil and the things that are moving above it?
Well, it's really light, so it's kind of going over, so everything can you get above it.
Okay, so the lightest ones are on top?
I think.
I think you're right. Okay, so this was the order that we put stuff in.
Yeah.
Did everything stay in the same order, or did some things move?
Some things move, but the honey's still on the bottom.
That's right, very good.
And then the yellow stuff is still with it, sort of, I think.
I think you're right. Do you have any other observations?
And the bubbles are colors that are not are not dark, are not very dark.
Very good. One more question. Do you think it might change or stay the same if we left it sit out for a long time?
Change a little bit.
How do you think it might change?
Because the lighter one, because more things might get above it, the vegetable oil and the colors might kind of mix together a little bit more.
Very cool. Thank you so much for helping me today, Ellery. I appreciate it.
You're welcome.
So it's not so hard at all to see that STEM is all around us and can be a great learning tool and experience for students of all ages and backgrounds. We can use everyday items, events, or concepts to have fun and engage young minds with STEM learning. Students love to learn, and STEM is a perfect area to engage them in hands-on, inquiry-based learning. It's easy and not complicated. It just takes your creativity, a little research, and a desire to have fun with your kids. The rest will come naturally.
We've provided some extra resources for you to get started with STEM. These resources come from a regional, state, and national organizations and those interested in using STEM with youth.
Thank you for joining us. On behalf of the Missouri Math and Science Coalition and the Missouri After School Network, look forward to future STEM-tastic series on STEM.